With that, I'm going to ask our first guest speaker, Dr. Kendal Harr, to come up. As I mentioned before, Kendal came all the way from Seattle, and in her spare time, she likes to scuba dive and travel with her daughters.
There you go. All right, there we go. So I am reporting on the avian toxicity project that was led by U.S. Fish, but certainly Louisiana was a close partner there. We actually represented all the 10 trustees, and I worked with DOJ closely. I'm reporting on over 50 experiments that occurred at 4 different sites in a 4-year time period. So this is going to be very quick and dirty. I'm going to talk fast. I'm still not going to get through all of it. I'm probably going to run over, just so everybody's prepared. Not too long. So this is what we know is affected in birds. Basically, oil hits every organ system. We did not test reproductive and endocrine. It was outside the scope of our purview, but we know from the literature that that occurs. When I say oxidative damage, I was told to kind of explain that. It's basically when oxygen reacts with tissues, it's facilitated by parts of the oil. It's essentially burning. Okay, you could replace that word with burning if you wanted to. I am going to focus in here on the circulatory system because these are novel findings that had never been reported before, not just in birds, but actually in vertebrate species higher than fish. So, and it is directly, I think, correlated with what goes on in humans. So I think it's a pretty important finding as well. Obviously, I didn't do this by myself. We had a very strong collaborative environment with both our government agencies, universities, and private agencies. And again, there were 4 sites that were used for the studies. Everything, not everything, probably 75% of the work is published in a special edition of Ecotoxicology and Environmental Safety. So I hope you all know this exists and have it and look at it. We do have some other data that's published in other places, which I'll highlight, and we actually have a couple more papers still coming out. Okay, so I wanted to hit pigeons really quickly because I think people in this room will be interested in the findings here. Our goal in this investigation was to address low-dose oil. So we all know that birds that are heavily oiled have about a 90% likelihood of death within the first 6 months released from rehab. So washing birds is not great for the birds. And if they do survive, they're very unlikely to successfully reproduce. So by the legal definition, they're dead, even if they are alive. It's different than low-dose oil. And the question is, you know, at what level of oil will birds survive over time? And so that was part of what we were doing. So what we were looking at is trace. Everything was less than 20% coverage. So in this pigeon, hopefully you can see that these brown wingtips are not normal. That is actually oil coverage. And then the tail feathers are actually oiled. It's about a teaspoon total of oil, so a relatively low dose of oil. We argued that this would be something that could occur because obviously if birds kind of sit in oil and they're spread out a little bit, those tips are what would get impacted. I don't have the up close picture, but what happens, I'm sure many of you have already seen it, that those feathers just spray out. They actually dissolve some of the quills there. And so that edge of the airfoil that's really required for them to get lift is completely damaged. And that change in the air movement prevents the birds from getting lift. And I should mention too that we had controls obviously for all studies, and we worked really hard. These are homing pigeons. The homing pigeons would always go back to the same place. So we had people watching on a 24-hour basis on the day that they would go back to grab oiled birds and get them out. That's an example of how we had to work to keep the controls control birds. In the pigeons, the only thing that we had that changed was evidence of muscular damage. I would say that that oil was placed on the birds only an hour before the flight. They did have some time to preen it out. It was very low dose oil, but they did not have a lot of time to sit there and preen. So we didn't get a lot of internal that, and we also had no skin exposure really, even though it's considered a dermal project because it's on wingtips. but we still got muscular damage. And so, you know, one of the questions is, okay, is it the oil actually damaging the musculature, which it absolutely can do directly with that burning of the toxicant, or is it secondary because these birds are actually having to work harder and it's generating hypoxia? We actually believe it's secondary, and that's just based on observation and the logistics. So these birds, very significant findings across the board in most of the studies, and I think there were 8 flight studies out of this laboratory. It changed the flight courses that the birds chose to get back, which is critical. They were choosing mountain areas, if you looked at a topo map, where the wind would go up and they could actually get lift and get up. They flapped harder, they were more exerted, they had more documented rest stops, so these birds are also tagged, obviously, as they're flying, and across the board, they had increased time to return. I want to point out one of the studies, because I think it's, oh, I think my pointer's gone, is critically, yep, it's gone, critically important to the survival of species, I think. So we ran one study, there were actually 3 planned, we only ran 1 in August, because what happened, we had 4 to 5 birds in the control group, 4 to 5 birds in the treated group, and all the control birds came back. They were heat exhausted, they were tired, it took them longer to get back than in other seasons, but all the control birds came back. None of the treated birds came back. We found 1 carcass. So the tags were picked up and the birds were already predated. So I think it speaks to, there's only so much stress that an animal can take. So if you, thank you, if you combine, there we go. I feel better. It's like my little, you know, toy that I can, like, my safety thing. So anyway, a whoopee, we call them. I think that other things to consider are the fact that all species are impacted very similarly with oil tox. It makes actually oil tox simple a little bit in the tox world of intoxicants because there is damage to all organ systems in all species. So it's not only the birds that are impacted, it's going to be their food sources that are impacted. You get population declines and death in some species. And so that in itself, getting nutrition in an oil spill is a stressor. So we already have 2 stressors that these birds actually didn't have to deal with because we're feeding them. So you add on a temperature stressor, a flight stressor, and other issues, and you know, it's not the same as some of the damage that we're just potentially causing in captive birds, for sure. Moving into the focus here is the 2 cormorant projects I want to focus in on. These are, we had an oral study and a dermal or a skin study. In the oral study, we injected low dose oil, so 5 mg per kg. It was actually around a teaspoon or 2 of oil on the low dose side into fish that were then fed out. Controls the fish were handled exactly the same with water sham. On the skin side, it was less than a tablespoon of oil applied every 3 days. We did not handle the birds except for every 3 days because we were trying to minimize stress there. So it was a total of 5 applications, so a total of around 4 tablespoons of oil applied dermally over about a 3-week time period. And we actually, in some birds, didn't apply the last application because we were worried we were going to kill them there. And we wanted to make sure we had complete collection at necropsy. So we unequivocally proved what we set out to do, that low dose oil kills birds over time. And I'm just going to show you a little bit of why here. One other thing I want to point out is this bird is a control bird. These are oil birds. We all said, you know, it's easier to smell them than to see them. So it's easy when you're hazmat covered and you're touching the bird to tell that bird's oiled. When you move 10 feet back, it's not so easy. As you're spotting out in the field, I think it's impossible. The amount of oil that will kill a bird is really hard to see on brown birds. You can see that in the services papers that they put out from WHO. It looks like white birds are overrepresented. Indeed, it's that the brown birds are underrepresented. And it's because you can see brown oil on white birds, right? I mean, it makes sense. Point here is we had, you know, a certain number of cages. This is a relatively low-end study. Controls are kept on one side. We tried to keep them separated from oil. There was aerosol exposure. We couldn't help that. We didn't consider that because we thought we were putting low-dose oil dermally. But if you can smell it in the room, it means they're being exposed, and we certainly could smell it in the room. So a little cross-contamination through the air that we couldn't control. Obviously, everything's thoroughly vented, but it is what it is. I want to point out, I'm not going to go through our statistical analysis, but I want to point out that the reference intervals that I generated for this project turned out to be the most sensitive way to detect damage. And that damage was backed up in other ways in the project. We would see it in a couple of assays. And so reference intervals are the ranges that you see when you get your blood work back from the hospital and your CBC chem. It's that thing on the right-hand side that you compare your value to and you say, is it normal or not? There's a reason we use that in medicine. It is because it's the most sensitive way to detect damage or changes, abnormality, okay? I'm gonna show you a good example. I have several actually, but I'm gonna show you one good example of where mean statistics completely fail to detect mortality essentially in the birds. Briefly, phase 1 and phase 2 oxidants, we found increase in all species in the project that I'm focusing on. We had a nice dose-dependent response. Our really low dose had less of an increase in our glutathione, which is our phase 2, so that's good. It's consistent with what we expect. And it is evidence as we move through here that we have oxidative damage that's likely leading to the changes in the study. Remember that we're doing this to make sure we can define this in the court of law at the time. Important, hepatic damage detected on histopathology was 0 in this study. We know we had, from measured biochemistry, we know we had significant changes. We know we had induction of enzymes. We know we had damage to hepatocytes. We know we had damage to the biliary tree. The histopath, which is when the bird dies, you take it, you cut it up, you put it under the microscope essentially, showed nothing. So when we have these dead birds that are minimally oiled and we bring them in and we think we're gonna send them and we're gonna diagnose this, it's not gonna happen. You're gonna miss it. The other thing is, as tissue deteriorates, you can't do the biochemical testing because it's rotten. It's not gonna work. You can do some biochemical testing, but it's really restricted. So the way to get to oil damage is in live animals, which means that we need to work a little bit more with our rehab centers and things on the ground to actually completely capture what's going on. I think the linear models that they created underestimated the bird damage in the Gulf of Mexico because they were not pulling in all of the factors basically that would contribute to no reproduction. Okay, so we're going to talk about circulatory. So that's heart, blood, vasculature. Anemia was definitively caused in the cormorants. We did not cause it in that pigeon study that I talked to you about. Again, only wingtips, makes sense. Laughing gulls, we think we caused it, but they stopped eating, so they were severely dehydrated. Can't assess anemia when things are severely dehydrated. We have the oral study, so green is always controls, and this is your reference interval, so this is your normal band right here. Green is always in the normal band, little variation, it's why we use reference intervals, because every individual is not the same. Our low dose, which is the blue line, and always will be the blue line, becomes anemic at around day 11. High dose becomes anemic around day 6. Consistent with what we saw in the induction of the phase 2s, our dermal exposure or oil exposure in the cormorants becomes anemic around day 12 as well. So the consistent value, and this is another key point, it looks like, there's variability here. The consistent value is the total dose of oil these birds are administered. At about 80 mg per kg of oil, all birds will show anemia. They will show the clinical signs that we saw: lethargy, obtundation. And it actually starts to occur around 50 mg per kg. Okay, so basically the point here is that if birds have a lower exposure rate, they will and are still kind of chronically being exposed because they're in that environment, but it's a low exposure rate because they're trying to move away, but they're still kind of getting in it, basically. It's just going to take a longer time for them to get sick because it's the total dose. Hopefully that makes sense. That's a really important point. So these birds would have died, okay? No question about it. If I had sampled them here at day 7, which is a week after the oil spill, they would have been within normal. So it's really important to think about how this all plays. It's complex because as soon as you put time into it, it becomes complex. Heinz bodies, they're important. It's basically burned hemoglobin is what it is. Very basic terms. My mentors would shoot me right now, but we're good. Anyway, again, the normal green is within our reference interval. We have a dose-dependent response over time. We do get some Heinz body formation that's increased in it beforehand, before they go anemic. Those red cells that are Heinz body damaged are getting pulled out of circulation and are not functional. So this is important because there's thousands of reasons for anemia. Heinz bodies focus it in on a toxicant. Oil is one of the toxicants that causes this. So in a court, and when you're trying to define legal, this says that, yeah, this says that yeah, now I lost my train of thought. So this defines in a court that anemia is due to intoxication. So that's important. I like pictures. This is normal. So these are very gray, homogeneous red blood cells. Whoops, wrong way. This is normal scanning EM, nice and smooth, flying saucers. That's what it should look like. This is what we see on the EM from oil birds. I had somebody backing up, another pathologist, for QC on everything. Super easy, 2-second look at it, oiled, not oiled. And that's in all dosage groups. Some more damage in the higher dose groups, but very easy to discern this. This is what it looks like on scanning EM. You can see all those bumps instead of the smooth. That is just glommed up hemoglobin and dead organelles sitting in there. This is what it looks like in a mammal. That's actually a rabbit. Humans look the same way. The body in humans tries to pit those out to salvage those red cells. It's not just hemoglobin, it's actually mitochondria. So this is mitochondria, membrane, Christie here. Hopefully you can see here, membrane, really damaged, smeared out lines, which are Christie there. Very important, mitochondria is where all of your respiration in your body occurs at every cell level. Not surprisingly, then the heart, which is the tissue that has the highest mitochondria concentration of any tissue in your body, is one of the most severely affected, but was not previously reported as being affected in vertebrate species, except in fish. Fish are the animal model for that. So echocardiograms never done before in cormorants. Little challenge, big bone, lots of air, things that are not good. They're very different density. This technique does not work well in bone and air. So Dr. Rupp, who is our boarded veterinary cardiologist who does echocardiograms all day, every day, she is fabulous, figured out a technique. And this is the one that we kind of went with. This is left ventricle, left atrium. You've got a 4-chambered heart here. So this is your best animal model that we have right now for humans. And end of story, we had decreased myocardial contractility and function in treated birds only. We also had arrhythmia in birds. This was published. We also developed troponin, which is the test that you are tested for when you walk into an emergency room. If you think you're having a heart attack, we did validate that in these birds. So it does work to define muscle injury in birds. We're not sure about oil. I don't have time to go on why, and that was published in Biomarkers in Toxicology this past year. So the normal heart rate, let me just show you this. No, I can't run it. Can you run it?
Run.
The video.
Is it in the embedded?
Yeah, it's embedded. So this is.
Yeah, it's running on my screen. So they're seeing it online.
They're seeing it online.
Mm-hmm.
Interesting.
I'm running the webinar.
All right, so a good online people are saying it because we're not seeing it. Okay, so the normal, I don't get an arrow at all to run this.
Well, actually, I'm on the TACHYCARDIA. I just realized I'm not on the moment.
Okay, so you're seeing what I'm seeing. You're actually running my screen?
No, I'm on.
Interesting. Okay, I have unfortunately, no arrow to show this. So this should have shown you the heart rate, which is normal, which is running between 90 and 200.
So the arrow is.
Yeah. Basically, we had increases in heart rate and decreases in heart rate. If you take the mean of increases and decrease, it zeroes out. So we had no statistically significant change between our treated and controls if we use mean statistics. And yet, we believe we induced atrial arrhythmia, which is the same thing that they have induced in fish, which is life-threatening at the time of the spill. People reported birds falling out of the sky. People were kind of like, oh, you know, this is like drama, this is Chicken Little, sky is falling kind of thing. The reality is that heart disease in birds causes them to fall out of the sky. So this is a potential pathogenesis for what people had reported and were dismissed. And so I can't show you this, but we had tachycardia greater than 300, and we had probably a dive reflex induced. So these birds are divers in hypoxic conditions. They are going to slow down their heart rate significantly, less than 60 BPM. We did not have a way to measure, set up the hypoxia we know we induced. We know we induced it because we couldn't restrain them in the same way. And so just to show you what this looks like, because this is what you're actually most likely to see. This is normal. If you picture a chicken heart, it's just about 2 to 3 times bigger. It's round, conical, triangular, firm. This is acorn shaped. It's saggy, it's droopy, it's flaccid. This is the experiment that we determined we had a problem where we set up the second project with the echocardiogram. You can see this. When you put it in the tray, it looks like Jell-O. So very clearly defined, normal, abnormal. Again, histopathology, nada. We know we probably killed one bird. We didn't take all the birds to necropsy because one of the treated birds did die. We know we probably killed one of the birds with this. Histopathology, 0. I got nothing on any of the treated birds. And I'm not going to talk to you about coag because I'm out of time, but the other thing we did define is that the birds don't clot. So it changes their clotting mechanisms so that they are not producing coagulation factors, probably, is what we think. And so what you wind up with, instead of normal feces, and this is how you can tell it in the field, you know, normal kind of soft, wet aquatic bird poop, brown, green, a little bile, basically what looks like clots of blood. And we confirmed that under the microscope that they are just shedding red blood cells out through their feces. There is no ulceration in GI tract. We ran every single GI tract on the treated birds. No ulceration at all that we could find anywhere, some parasitism. This is happening because they literally can't clot. And if you can't clot, you bleed out through your intestine. And caused by bone marrow, liver, kidney, probably all of the above, getting in there to cause that. 200 ml per kg is a total dose death with the toxicant that we used, which was an artificially weathered MC252. And that's it. We don't have time for questions.